Hello friends, today my problem is design a simply supported beam. Here we observe a question. A design of simply supported beam of single reinforcement carries out 20 mm superimposed load. Over the beam span is 4 mm, beam span and 3 mm width. We use a M20 gate of concrete and FCK, that means steel, gate of steel 415. Kindly check for the necessary conditions of design of concrete. Here we observe that the given data required for do the problem according to the question is width of the beam is 200, span is 4 meters, and superimposed load is 20 kilonewtons, and this FCK is 20 and Fy is 415, and we have to just first step 2 to determine the depth required of the beam. According to IS code, the depth of beam determined by D is L by 2 to L by 12 to L by 13. Again, our problem where span is 400 meters, 4000 meters, then D is equal L by 2 by 12, that means 33.3. We can get it under 33.50 for our consideration. And step 2, determining out this effective span. For determining effective span, we require both spans and the length of the beam, and the length of overall span of the beam. Overall span of beam 400 meters, and both sides of the effective length is 300 by 2, 300 by 2. We have to take half of the beam, that implies 4300 mm. And a clear span, that is clear span with effective depth, where clear span is a 4000 meter, effective 350 meters, that implies 4300 meters. Consider left side. And design of the load. And design of load having design of load determine how much load will be determined, otherwise how much load will base of the beam. That means self weight of the beam, this area into length into unit weight of the RCC. Area of the beam is B into D, that means it is a rectangular shape section in a unit area 1, and the unit weight of concrete is 25. Then according to the problem we found that 300 into 350 into 1 into 25. Then superimposed load. According to the problem, superimposed load is 20 kilonewtons. Then total load is superimposed load plus all other loads we have been calculated, that is 22.626. And the factor load. The factor is very important for design beam, that is 1.5 22.625 kilonewtons. And factored beam moment, that is MU is equal to W squared by 8, that implies MU is equal to 78.25. And shear force is WL by 2, that is equal to 3.95 into 4.35 by 2. Our answer is 72.9 kilonewtons. And the main important thing is the depth of the beam. Depth of beam have been determined according to IS code, that is MU is equal to 0.138 FCK into BD square. In that time we have determined D depth, that is D. The answer is 307 into 82.mm. Finally, the provided is 350. Why? Because we have to take a constant values of both of them. Tension reinforcement, at how much tension will be bases the beam of the concrete, that is MU is equal to 0.87 Fy AST into 1 minus Fy into AST by FCK into CD. The formula is having in IS code. Then according we have to calculate the area of the steel, that is AST. For above calculate AST is equal to 72.622 mm square. After determining of the area of steel, we need to determine the number of bars. That implies AST, the capital A AST by small a AST. That implies capital A AST means tension reinforcement, small AST means providing reinforcement. And assuming that 12 mm bars are 4 nodes diagram, we are assuming the diameter of bars 12 mm dia, and AST and AST I will turn on provided reinforcement of steel, that is pi is equal to 12 square by 4 into 4. The answer is 452.38. And finally the final provider of beam for second section, that is 16 mm diameter at 4 bars. Okay. This is span of bars. The span of bars is determining of the spacing. Next is determining spacing of the bars. The spacing of bars, that is called AST by small AST, that is AST by small AST means that number of brasses into 100. The answer will come is 100 mm cc. Next, check for deflection. Check for deflection we generally know that formula is L by D ratio. L by D ratio is equal to 20. Then a percentage of the steel. The percentage of steel determined by IS code. We have a table. AST by B into D. Then the provided steel is 0.64. Again, determining the FS. This formula is also in the IS code. The IS code provision also. IS 4. Then according to IS 456-2000, the modification factor will be 1.2. The 1.2 into FCK. 1.2 FCK is equal to 1.2 into 20. That is by L by D ratio. Then L by D ratio is 42,000 by 315, 12.5. It is less than 20. That is my BB sections here. Here we observe that what we observe means overall cross section of beam will be 4,000 meters, and we given that effective span is 350 into 350, and the width is 350 meters. And finally, we determine the board shape is 1,000 mm spacing. Overall effective span will determine 4,300. Here the main thing is span of beam is 3,500 and 16 mm diameter of under reinforced section, and the cross section will be provided. Thank you very much. Next class will be determined by some more videos.